Okay, so now what I want to do next is I want to do a few more examples with a system of linear equations. And again, we're solving them now using that method of elimination. Some books call it addition. If you remember, the whole idea is you want to somehow multiply the equations by numbers so that if you were to add them, one of the variables would disappear, would go away, would cancel. Okay? So essentially, it's another way of killing off a variable, so to say. I mean, if you looked at substitution, essentially, in the end, we're doing the same thing. We're somehow eliminating one of the variables. And in elimination, we do the same thing. It's just that what we do is we add the equations after we multiply them by numbers if necessary. So here we have these two. Now, we could just dive right in, but notice we have these 7s in denominators. I mean, that's not terrible, but I think it could be better if we didn't have those denominators, right? You know, this would be a little bit easier if we didn't have these denominators. Well, let's eliminate them. How do we do that? We're going to multiply both sides by 7. So if we multiply both sides of this equation by 7, those denominators are going to vanish. It's kind of like, if you remember in chapter 1, when we were solving equations in one variable, remember how we had fractions, then we had to multiply both sides of the equation, right? By the least common multiple of the least common denominator, which is the least common multiple of the denominators, right? Remember, we had to do that. It's the same idea here, except the denominators are the same. So you just multiply by that denominator. And that's what I'm doing here. So I multiply both sides by 7. Doing so, we distribute. I tried to write a 7 here. Hopefully that looks like a 7. When we distribute, as you can see, the 7s, the denominators, are going to vanish. But whatever you do to the left, you do to the right. That's why we have a 7 here. So we have minus 7 times y. Like so. So again, for the first equation, we took the denominators away by multiplying both sides by that denominator. All right. Awesome. Now our system looks like this. Okay. Now, so now, looking at this, if we would add the two equations right away, right? Well, the x and y's are not going to cancel. You know, that's not going to happen. Well, then they're not going to cancel, right? Because the coefficients would not add up to 0. So if I added these two for negative 11x and 5x, that's not going to add to give you 0. Negative 7y and 2y, that's not going to add to give you 0. So we have to multiply the equations by numbers. You know, we have to manipulate them. But what I can do is I can multiply the first equation by 2, the second equation by 7. What will happen then is the coefficient of y will become negative 14. Down here, it will become 14. And that's what I'm doing here. So I can multiply the first equation by 2, right? And what happens is the coefficient of y becomes negative 14. The coefficient of the second equation becomes 14y, 14. And now, if we add the equations, those y's are going to cancel. We have to handle the left side as well. So we're multiplying the left side by 2, as you can see, right? So we have negative 2, we have 2 times negative 5, and minus 2 times 11. So we have negative 10 minus 22x. Here, multiplying by 7, we get 49 plus 35x. And now we can add the equations. Again, the whole point is, remember, you want it so that when you add the equations, one of the variables disappears, cancels, x or y. I'm really choosing y arbitrarily. I could try to cancel x. But when we add here, initially, they're not going to cancel, right? So we have to manipulate the equations. We have to multiply them by certain numbers so that when we do add the variables, those variables cancel. And I'm multiplying the first by 2 and the second by 7 because then the coefficients of y will cancel once I multiply. And that's what's happening here. So when we add the equations now, right, what happens? We have minus 22 times x minus 10 equals minus 14y. 35x plus 49 equals 14y. That's the second equation, right? When we add, those y's are gone, as you can see. These numbers here become 39, right? When we add the constants, coefficients of x, the x that is becomes 13x. That becomes 13x, as you can see. So we have 13x plus 39 is 0. Right? The y's are gone. So now what do we do next? We subtract. Now we want to solve for x, right? It's a lot easier because now we only have one variable. We have an equation in one variable, and we know how to solve that equation. We just do what we did in chapter 1, right? We isolate x. So I get the 39 on the other side by subtracting, right? We want to get x all alone. So 13x equals negative 39, as you can see. Then we divide both sides by 13, as you can see, right? Because we have 13x is negative 39, but we want x all alone. So we divide by 13. Doing so, we get x is minus 3. And really, that's the hard part, okay? Really, that's the hard part. So we get x is minus 3. Let me just summarize again. Oh, there we go. But again, let me just say it again. By elimination, we can't, if we add the equations right away, nothing's going to cancel. The variables won't cancel. But what we can do is multiply the first one by 2, and the second one by 7. Then this becomes negative 14y. This becomes 14y. You add them together, then the y's cancel. And we get one equation in one variable, which was x, and we got x to be negative 3. But are we done, though? Well, no. Remember, we have to handle the other variable. We have to figure out what y is. For that one, you can use either equation in the original system. So you can use either of these equations or these equations. They're the same. I mean, they're equivalent, meaning their solution sets are the same. So using either equation to get y, and I used the second one, I think. Yeah, I did. Here. We have 2y equals 7 plus 5x. So we have 2y is 5 times negative 3 plus 7. Again, this was 5x, but I replaced the x by negative 3. And again, we have one equation, one variable. And we just solve it like before. Here we can combine these terms to get negative 8. Divide both sides by 2. Because we have 2y, but we don't want 2y, we want y. We want to get y all alone. So we divide. and we get y is -4. As you can see. Now that y is -4, now we're done because now we know what x and y are. So x is -3, y is -4. And that's our solution. Okay. All right. Okay, now also, you don't have to do this, but it's good to check. I mean, you could just check by substituting. We can also check using decimals. Let me just stop the recording.